We are covering 8.3, chapter 8, section 3, proving similar triangles by side, 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 and side, angle, side. So last class we did angle, angle, and now we're proving the triangles to be similar. Please make sure you understand there's a difference between your similarity symbol. So similar is the squiggly line. Congruent is the squiggly line with the equal sign. So when you were writing these, for those of you who did it on the quiz, make sure you're understanding the difference between your similar symbol and your congruent symbol. You have to know that. All right. Side, side, side similarity theorem. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So they're giving me my similarity statement. I need to write if the sides are proportional. So AB, I'm going to go from right to left. So I'm going to put my right shape on the top and my left shape on the bottom. So looking at it, I'm going to have 4 over 8, 3 over 6, and 5 over 10. If I were to simplify all of these, okay, if I'm trying to find my scale factor, my simplified ratio, what's 4 over 8 simplified to?
1/2.
Good. What about 3 over 6?
1/2.
And 5 to 10? Good. So these are similar triangles. They have to have the same proportion for each side. And that's what's giving me my side, side, side.
It's always right over left.
Yes. I would keep it right over left so we're all doing the same thing. All right. Side, angle, side similarity theorem. If an angle of one triangle is congruent to the angle of the second triangle, so you need one triangle, one angle is congruent to the second triangle, and super important that you have the word "and" there, the lengths of the sides including the angles are proportioned. So we should know what including sides are. We did side, angle, side. So you should kind of have an idea of what this should look like. We did side, angle, side congruency theorem. Now we're doing similarity theorem. Then the triangles are similar. So looking at this, if I were to look at this, looking at my sides, I'm going to do same thing, right over left. And I'm doing 4 over 8 and 5 over 10. Again, simplifying these, I'm going to get the same thing as I did before. And because these sides are similar, they're proportional, the angle is proportional. Okay, normally they would give you the angle, they would show you the angle, but it has to be the included angle. Okay, and I'm going to add a page and I'm going to show you what some other examples that will not be similar are. Alright, so I'm going to write underneath, you guys should just add a page. I'm going to give you an example for this on what's not similar and what would make it not included. So if I gave you two triangles, I have 5, 6, 8, and 10. We should know that the vertical angles are congruent. We automatically know vertical angles are congruent. Looking at this, if I want to find if my sides are proportional, I would have 5 over 10 and 6 over 8. Simplifying 5 over 10, what would I get? Good. And simplifying 6 over 8, what would I get? Good, 3 over 4. Are these ratios, are they proportional? No, these two are not proportional, so it's not similar. These two shapes, these two triangles are not similar. Again, their proportions are not the same. All right, looking at another example I'm going to give you. All right, I'm going to give you 5, 4, 8, and 10. Verticals we know are congruent. Setting it up as a proportion as I did before. I have 5 over 10, 4 over 8. Simplifying these, I'm getting 1/2. So they the sides are going to be proportional. However, these are my sides that are proportional. Is my included angle congruent? No, good. Okay, so looking at it, these two angles right here, this is not the included angle. Okay, remember it has to be the included angle. For it to be the included angle, it would have to be right here and right here. So you need this angle. Okay, you need those two angles in order for it to be side, angle, side. It has to be the included angle. Not any angle, it has to be your included angle. All right, this chart shows you all the similarity postulate and theorems. So previous class we covered angle, angle. We covered angle, angle, similarity. Keep in mind you have to have two angles that are congruent, so super important for you to know that. Two angles that are congruent. Side, side, side. You have to have all your sides to be proportional. So this is my proportionality statement, my statement of proportionality, which I had you guys write on the quiz. And then the last one for side, angle, side. You have to have two sides that are similar with the included angle. So when I'm looking at this one, I'm going to highlight it. I have my two sides, which is A, B, and D, E, and then A, C, and D, F. They're giving me my included angle. Okay, it's my included angle that's incongruent, not any angle. It has to be the included angle. All right, looking at example number 1, A. It says the measure of the sides of ABC are 4, 5, and 7. And the measure of the sides of triangle XYZ is 16, 20, 28. Are the triangles similar? So looking at this one, I would draw my triangles. I have one triangle here. I have A, B, C, and then I have triangle X, Y, Z. Labeling, I have 4, 5, 7, 16, 20, 28. I need to figure out if they're similar. So setting up as a proportion, I have 4 over 16. I have 5 over 20. And I have 7 over 28. If I were to simplify all of these, what would I get? For good, 1 over 4 for this one, 1 over 4 for that one, and 1 over 4 for my last one. So are these triangles similar?
Yes.
Good. All right, looking at it, these are similar, so it's yes. Even if you did right over left, your scale factor would still be 4, so all my sides would still be the same. So, yes, for this one I did left over right, but we can do right over left. So it's yes, they are similar. And normally if they're similar, write a similarity statement. So triangle ABC is similar to triangle XYZ, and that's for A. All right, looking at B, it says triangle ABC. So AB is 2, AC is 5, BC is 6. And triangle XYZ, XY is 2.5, YZ is 2, and XZ is 3. Are they similar triangles? So same thing as we did before, set them up as proportions. I'm going to have 3 over 5. I'm going to have 2 over 6 and 2.5 over 2. Can I simplify 3 over 5? No, I'm just going to keep it that way. Can I simplify 2 over 6?
1 over 3.
Good, 1 over 3. Are these the same? No, so I can stop right there and I can give you my answer. Are they similar triangles? No. not similar. I don't even have to do that decimal. All right, example number 2. I'm going to label these because they didn't give me any measures. I'm going to have 2 right here. I'm going to have 10 right here. I'm going to have 4 and 2. So first thing they're asking me for is triangle XYQ. I'm going to draw XYQ. Let me highlight it so you know which one I'm drawing. XYQ. So this one in purple, I'm going to draw it as best as I can. XYQ, and I'm going to label it. This is 4. What's XY? What's the measure of XY?
12.
Good. I'm adding 2 plus 10. That's going to give me a 12 over here. I'm going to go ahead and do my other side. I have X, Z, P. Okay, so I'm going to go ahead and draw that one. I have X, Z, X, Z, P. And then labeling what I have. I have 2 over here. And then what's XZ? You could tell me, what's XZ? Good. Perfect. Good. Thank you. It is 6. So looking at this, do I know any shared angles?
X and Y.
Not X and Y. It's just one angle. So what angle looking here is being shared? Just X. Okay. X is being overlapped. So I can tell you that those are being shared right there. Okay. They're going to be shared. Now I need to find, are my sides proportional? So looking at this one, looking at my sides, I'm going to have 2 over 4 and 6 over 12. 2 over 4 simplifies to 1 over 2. And then 6 over 12 simplifies to 1 over 2. So are these proportional?
Yes.
Yes, using what?
Side angle side.
Good, side, angle, side. All right, and they also asked, does it follow that XPQ is similar to XYZ? So let's go ahead and draw that one. XPQ. So this is congruent, and this is 2 and 4. And X, Y, Z. And this is also congruent, and this is 12 and 6. It's the same thing we did before. 12 over 4 and 6 over 2. What's 12 over 4? Good, 3 as a whole. And the same thing over here is 3. So yes, are they proportional? Yeah. By side, angle, side. All right, example 3. I definitely recommend to draw them out. So looking at this one, I have A, D, E, and we know this is 80 degrees. And then I also have A, B, C, and again, this is also 80 degrees. What else are they sharing? Good, they're sharing angle A. So I know that these are congruent, or not congruent, sorry. These are similar using which theorem? No, it's not SAS. Angle, angle. They're only giving me 2 angles. I showed you that 2 angles are similar or are going to be the same measure. So this is angle, angle. So triangle ADE is similar to triangle ABC. And that would be my answer. Questions on A? You have to remember the difference between angle, angle, and side, angle, side. All right. Looking at B, Again, drawing it out definitely helps. I have C, D, E. I have 6, 10, and then I have my larger one. I have C, A, B, and I'm adding them. 6 plus 3, what would I get? Don't forget you have to add them. 10 and 5, and I'm going to get 15. Are they sharing any angles? Good, they're sharing angle C. So I know this is going to be congruent right here, so I'm going to draw my congruency mark because they're sharing it. And then now we just have to find out about my sides. We'll do it the other way, we'll do 9 over 6 and 15 over 10. Simplifying these. 3 and 2, 3 and 2. Are they the same if I simplify my ratios? Yes. So this side is the same ratio. This side is the same ratio. What would this one be considered? Good. Side, angle, side. And my congruency would be DCE. Or not congruency, my similarity. And triangle ACB. Okay, those are similar triangles. And then the last one, again, this one should have helped if you drew it out. L, M, K, you have 3, 5, and 6. And then you have your larger one, O, N, K. OK is 6, O, N is 10, and what's K, N? Good, I have 6 plus 6, which gives me 12. Okay, Ms. Chung, I don't know which ones match with which. Okay, please pay attention to this. How I am matching them is 3 is my smallest side, 6 is my smallest side for my other triangle. Okay, so where am I getting these? From this one and this one. Then I have 5 as my middle one, 10 is my middle one. So 5 over 10. And then the last one I'm going to have is my larger sides. So that's how I'm matching them. Always do it that way. 6 and 12. Simplifying them now. What's 3 over 6 simplify to? What about 5 and 10? And 6 and 12? So are they similar triangles?
Yeah.
Using what? Good, side, side, side. And then I have triangle for my small side, K, L, M is similar to triangle starting from my small side, K, O, N. And I'm done. Questions on these? All right, you guys, this is the third lesson. You guys are having your test on Wednesday. So we have one more lesson. You guys have homework on big ideas.